Or a conference call?
No, yeah, you're not lab.
How many advanced degrees you need for a conference call?
I think the more advanced degrees you have, the less conference call works.
Yeah, I'm pretty sure.
Okay, so start?
Yeah, you can introduce yourself and give us your ages.
So my name is Siddhant Desai. I am 13 years old and I live in Parsippany and I go to Brookline Middle School. Parsippany is in New Jersey.
Yeah.
Hi, I'm Kian Goda. I am 13 years old. I live in New Providence, New Jersey, and I go to New Providence Middle School.
My name is Om Desai. I am 12 years old and I go to New Providence Middle School, which is also in New Jersey.
Cool.
So let's start. So the problem that we're trying to solve is a major paradox. Every day, thousands of people go hungry and don't have anything to eat, while thousands of people are throwing away perfectly good food. Almost 33% of produced food goes to waste. So our idea to solve this problem is to make a product which makes other people aware of how much food they are wasting. So have you guys ever tried to measure how much food you've wasted per day? Like if you don't know how much you're wasting, how can you get better? Well, that's what our product does. It records how much food waste that you have every time you throw out food, and it displays it in neat graphs and charts, and it puts it on your phone into an app. So this way you can have visual data to help you see trends and how much food you're wasting over long periods of time. So our product is called the Waste Watcher, and Jan Goda will demonstrate how it works.
So imagine you're going to Home Depot or Best Buy and you buy this product called the Waste Watcher. It's flexible inside so it can fit any trash can you want. You go home and you go to the kitchen. You adjust the size of the waste watcher so it fits the size of your trash can and put your trash can on top of it. You start the waste watcher, calibrate it, and you start the waste watcher, you calibrate it, you pair it up with your phone. Now your trash can is smart. It shows you how much food you're wasting. And then you throw, let's say, 0.5 pounds of food into the trash can. Your phone buzzes and it tells you you wasted 0.5 pounds of food. Now that's what our waste watcher does. Right now in our prototype, we use load sensors, a Wheatstone bridge configuration, and an Arduino microcontroller, which does the same thing as it will in the final product. The only difference is that right now the wires are outside of the unit, and instead of it being able to connect wirelessly to your phone, it communicates with the computer through the serial port. So let's see the waste watcher in function. So can you please press connect with the mouse to connect? Okay, so as you can see, clears the Excel sheet. So if I put something in, and then if I put something else in, and it creates real-time graphs, as you can see right over here, of how much food you're wasting. And even if you put two things in at once, it can still handle it. And if I take stuff out, it minuses the weight that it takes out. And okay, went up. And as you can see, we go back to 0. Now, since these load sensors are a bit unstable, it will sometimes do that.
So why do you want to subtract? Because if you're measuring your total waste, right, and you take it out and throw it away, why? I'm not wasting that.
What I meant to say is that it just takes the weight that's on the headset.
Okay.
I accidentally said minus.
But shouldn't your Excel sheet, instead of coming back down, maintain that same amount? Because you've wasted that same amount.
Can you please elaborate more on what you said?
So if I'm looking at this as a total amount that I've wasted, correct? Let's say I just took out the trash, right? As you did, you took out everything you wasted, the total amount of waste I have is not zero. It's still whatever that value was.
It shows you how it's like wasting daily. So
Yeah.
like you can see different amounts of improvement over time.
Yeah, so let's say, like, I can elaborate on that a little bit. Let's say when you go home at night, you just take out the trash. Now the next day, you're gonna have 0 pounds again. So when you put in more food, it's gonna add up, and you can see your trend on like
But
today I
that's-
wasted.
So it tracks it every day. So you
Yeah.
can say, okay, so today I wasted 10 pounds,
today I
yesterday I
wasted
wasted
this, and then
5.
it'll show graphs
Why don't
like
you show
that.
them the trend on the mobile phone?
Yeah. So, like, as you can see, the trend right over here, it shows you how much food waste, your daily food waste. So that creates a trend.
So daily food waste in pounds. So it's showing you that your food waste is going down.
One question. You said that before using it, you calibrate it. What do you mean by calibrate?
I'll get more into that later.
So now I'm going to hand it over to Owen for
So what you just saw was a demonstration of how this product works. So now I'm going to explain the scientific principles and product design behind this. First thing you need to know is that this trash can doesn't come with the scale. You could just bring this scale, it can come in any size, and you can use your own trash can, and it's portable, so you can put it in any area of the house you want. So now let's say you put some trash in like this. And the first thing it does is it trips off load sensors in the 4 corners of each scale. And these create resistance, which is sent to these 12 wires. This then goes into a spark plug company, which basically produces a sprint, in which it uses Ohm's law to convert resistance into voltage. It then sends that stuff into the spark plug amplifier, which converts the signal from analog to digital so the microcontroller can read it, and also amplifies the voltage. It then sends that to the Arduino microcontroller, and this is where our program runs, in which it calibrates it, because this has weight. And we wanted it to start at 0 with the trash can on it. So it calibrates it, converts the weight from voltage to pounds, and displays the weight by sending it through this software called Stack. And what this does is it puts it into an Excel sheet and sends it to Microsoft Power BI, which integrates all this data into a web app.
Who has written the program? The first question. And the question is that how do you, in real time, basically draw this picture, these graphs in Excel? So that's the.
You can make graphs in Excel. This is make graphs in Excel.
No, you can make the graphs in Excel. So have you written that program? Who has written the program to create this?
We all work together, share that program.
And when it takes the data, it just puts it into Excel, and we have code that converts the data into charts and graphs.
For a final project, so right now you're using the Arduinos and the Pi, which I'm impressed with. That is a Pi, right? Pi 1? Is that a Pi?
That's an Arduino.
Yeah, it's a new node.
But so then it goes into this computer where you're running Windows and Excel, which, especially recently, not everyone runs Windows and not everyone runs Excel. There's lots of tablets out there. There's a lot of people with only iPhones or tablets or Macs. What are your thoughts on replacing the Excel portions of this, or develop proprietary portions of this for other software?
we already have thought of that, and we have created a Microsoft app, as you can see, our Microsoft Power BI app, which lets people see how much food they're wasting from their phone or tablet or wherever they are.
And eventually, we want to make it wireless, so you will be able to come to pretty much any device.
So it doesn't require Excel?
No,
It
no.
doesn't require Excel. This is just for the prototype. So
One more question. This is like waste voucher for the food. As soon as you put a bottle there, so the bottle, like an empty bottle, it's not food. So how do you detect that it's like?
We've thought of that. You can use this red trash can as sort of like a symbolism. Like you can have, you know how blue usually means recycle? Well, what this means is that the red trash can basically means that only food waste goes into here. So you can have a universal symbol that says sort of like, okay, red trash can, that means food waste.
It doesn't necessarily have to be this red trash can too. You can just separate your trash cans into food waste and other waste.
Yeah, so like, symbolize, you can symbolize each food waste as red or any other color. Yeah.
How would you power the unit? Would you plug it into the wall or have a battery you would replace?
We'd have a battery.
But is this unit always on, or does it only test every X number of seconds?
It's always on. It's always so every time you put in a weight, it has a every time you put in weight, the Excel sheet in this case right now for the prototype will update. So it's always on, but the weight won't change unless you put something else in.
So how do you think that'll affect the battery life?
How long does it work?
What do you mean by that? Like,
So if you have something that is, if you look at your, let's say your scales for humans, right? Those digital scales, those are not always on, right? It's not on until you step on it. And then that way when it's off, instead of keep sending signals or whatever, which uses up battery life, it conserves that battery. So it's not on until you step on it. So why do you think that is versus an always-on
So
design?
the battery life would drain, but here we're using rechargeable batteries and not like normal disposable batteries. So in this case, you really don't have to pay any more for batteries. You
But
can
I have to go in and change it.
yeah.
So wouldn't it be easier if you have something, since you have this always at the same place and you don't need to move it, to just either have a not always on unit or a wall plug in?
That could be something
that can
definitely
be
take
Yeah,
into
different.
thank you for the suggestion.
Take that into consideration.
No, I'm just wondering what your thought process is. Because it's always, you could think of things that I haven't thought of or whatever.
So, in the waste management unit, integration and automation is the story. But software plays a vital role in that too. We have three main components for our software. One of which is using an Arduino Sketch program to calibrate, measure, and log the weight into an Excel file. The second component is using a software called Parallax DAQ to retrieve the data, log in the data, and visualize the data for the user. And the third component is using Microsoft Power BI to create a mobile app which people can view from anywhere and from any device. So let's talk about our first component, calibration. So what is calibration? Well, before we want to actually start measuring the weight, you want to make sure that you're getting that the output of the weight you're getting is the right weight. So let's say I'm placing a known weight like 1 pound into this trash can. You want it so that it outputs 1 pound into the computer. You can do this by changing the calibration factor in the code. And you can do that until it outputs 1 pound. And you can monitor this weight change by using the serial monitor in Arduino. Now, this unit is already calibrated, and calibration happens in the second program. So what the second program is that it's the main program of this program. What it does is it measures the weight, it initializes the Parallax DAQ's Excel file, so it defines the columns and etc., clears the Excel sheet, and what it also does is it starts logging the data into Excel. So a main key component we have in that program is we only display the weight or send the weight to the computer when there's a change in the weight. We monitor this by using conditional statements, and we also added a 2-second delay so that if I put something in, it'll wait 2 seconds before it shows the weight to stabilize the weight. If you have any questions on what I mean by that, feel free to ask that during the Q&A session.
Which has been ongoing.
So both of these programs use the HX711 SparkFun library to call in functions and to calibrate and measure the weight. The second program, which is the main program, also uses Parallax DAQ's library to help integrate with Microsoft Excel. So in the future, future, we want one single program that calibrates, measures, and logs the weight into Excel. Now let's talk about our second component, Parallax DAQ. What Parallax DAQ is that it's an open source software that has a set of macros in it. We have not changed the macros at all, and what the macros basically do is that they just retrieve the data from the Arduino microcontroller by the serial port, and then log that data into Excel. The only thing we've added is we've added these real-time graphs here, so that it helps visualize things for the user. The third component is the use of this Microsoft Power BI. So this demonstrates the Waste Watchers mobile app concept, and how we use Microsoft Power BI is we use the same Excel data gathered from this prototype, which was gathered from multiple days, and added some additional data to categorize the food as shown here. And this Excel file is used to define the Microsoft Power BI app report for Waste Watchers. And this report is then published to the web, so you can view it anywhere at any time at any device.
As you said, you can divide different, you can have different batch pins, so attach. So the question is that if you have multiple of these things, can you connect all of them to one Arduino board and draw like multiple graphs simultaneously? For instance, you have like trash water, you have cans and all. Can you show, because at the end of the month you want to see how much waste you had for the bottles, how much you had for, have you thought about it? Basically
Excuse
connect
me.
all of them.
So if you haven't participated in round 3 of the mystery maze, please come down to the front. Thank you.
Yes, it is possible to connect to these skills on the way.
And will the Parallax DAQ detect which input to the Arduino is changing, so it'll output into the Excel?
Yes.
So if I throw in an apple, it'll say, okay, that was fruit. If I throw in a hot dog, it'll say,
You can say, okay, that was
Right now in this prototype, you actually need to manually enter in
Yeah,
what
yeah,
food
yeah.
you have
Yeah.
because it can't detect what food you
no,
have.
that makes sense.
Sensors to detect
Yeah.
that. But maybe in the future we can add that.
Yeah, that's cool.
Because but the good thing about this is that that's the only thing you need to add. As you can see from this Excel data, you only need to add what type of food you wasted because all of this is automated.
So have you used this and seen if it actually reduces your waste? Have you used it in your own homes?
I've used it for a week, and as you can see, it helped me
Yeah,
reduce
that's
my food
awesome.
waste.
Yeah, so he had this at his home for
That's
1 week.
fantastic.
Yeah, that's awesome.
So now that you've heard of our prototype, let's talk about our final product.
Okay.
So on the hardware side of things, we want a portable model. We want a flexible model so it can fit any sort of trash can you want, so you don't need to buy different size Waste Watcher units. And we want it to connect wirelessly to your paired phone by the use of Bluetooth Shield. On the software side, we want data analysis and pattern finding algorithms, so eventually it can start giving advice to the user saying, hey, you're throwing out a bit too much like meat, for instance. Maybe you should try cutting down on meat. And it can find patterns in your food wastage. Another thing we want to add is a centralized data storage so everything is stored in one place. And we also want a whole social community so people can share and talk about how much food they're wasted, and it can become a whole Waste Watchers community.
We need this
So
because
like,
I'm
this is
So as you can see here, there can be like contests and stuff.
You can tweet your
Depending on
waste.
your score.
Yeah, so like this would be like your score. You could have a rank of like, oh, I'm so bright, waste less food than everyone drinks, or something like that. Yeah.
It's social shaming, they call it. So
Yeah,
you tweet it, be
social
like,
shaming.
you just
Yes.
wasted an apple. Oh,
And we also,
yeah, exactly.
and on the software side, we also want it to connect to the paired phone.
Yeah. Do you have any ideas, I know it's in the future, what software you'd like to use for this sort of one controlled unit? So obviously you probably can't use Excel because that's on Windows and it's not easy.
No.
Not right now, but right now we have a
We're thinking about using like Google Sheets or something like that because it can be stored in Drive. And as you can see, all of the major things that we needed our wastewater unit to do, it's all in the prototype already. So we're not that far from having our final product.
I'm not saying you should do this. I'm just asking you.
No.
He's a big open source proponent.
Anyway, so I have a recommendation. If you look into the language Python, Python can read from the Arduinos, Python can write to the web page, Python can do all the data analysis and plotting all in one package, if you will. So potentially Python is something to look into.
Thank you for that suggestion.
And
We'll look into it.
on the same note, if you want something that isn't always on, if you want to keep the battery, like the reason the digital scales work, they have something called a piezoelectric. Do you know what that is? So a piezoelectric, when you mechanically deform it, it sends out an electric signal. So when you deform it, for example, when you put something in, that deforms a piezoelectric, and that can send out. Well, it is a piezoelectric, but it's also you can use it to turn it on.
Yeah, that could work. Thank you very much for the
That would
suggestion.
save a lot of batteries.
Yeah.
Good.
All right, excellent. Thank you so much.
Yeah, well, did you have anything else, or were you at the end? We keep
Sorry.
interrupting. We
We're very-
apologize.
Do you have any other questions?
No, you've covered everything very well. Yeah.
Thank you.
Cool. Thank you.
And
Excellent job.
Remember, save food waste.
Yeah.
Absolutely.
Excellent.
I eat everything I buy.
I try to.
Very good job, guys. Really, really nice.
good.
Yeah, thank you for dealing with our questions.
We're inquisitive folks.
We will.
Yeah.
Thank you. Yeah, this is really nice.
Good job, guys.